Hello everyone, good morning and welcome to the class. Can you all see the screen?
Yes.
So today let's get started with the first tool in our course, the Git version control system. If you can recollect the yesterday's pipeline we have discussed, just let me share that as well. Just give me a second. So this was the one we are looking into, right? In the yesterday's class, like we are having an overview, a high level discussion on this. Like this is the pipeline. This is how it starts from Git. Like developers place the code there on Git, and DevOps team pull the code and create this pipeline, right? So like what is Git? What is the version control system? How it works? So we are going to zoom into this part. And why do DevOps team should learn this Git as a version control system? What are the aspects of learning it? All of these things we will learn here from basics till advanced part. So we are going to zoom into this now. So let's get started with this. And yeah, it will take some days, like couple of days to master this. We'll learn from basics till all the concepts from the different perspectives how DevOps team uses it. So let's begin. So let's get started with version control system. So first let us understand what is a version control system. Why do we need this? To understand this, let me give a very simple example. Let's say there is a project, there's a team of people working. Right, they might have placed all their project, all their files, all their config files, whatever it is, on some shared location or the shared drive. Right, so all the files were kept here, like file 1, file 2, and so on. And multiple people are working on this, like person A, person B, both of them are working on it. Let's say both of them have to work on the same file at the same time. Person A got this file to his local computer, file 1. B also got this file to his local computer. They made changes and person A kept this file back on day 1, right? Person B kept his file back on day 2. So this file 1 on this remote or the shared location will have which person changes finally? This file 1 is going to have which person changes on this shared location. Here I'm talking about a general use case without using version control system. So there is no version control system and people are working on the same file at the same time. They place the file this way. So which person, I mean, the file is having which person changes finally. Can anyone answer this?
Maybe only the second one.
Like only the file 1 will have person B changes, the latest changes, right? The latest updated changes because person A changes are being overwritten by person B changes, correct? So what is happening here? A changes are overwritten by B, correct? So if this keep on going, like what happens? The project gets messed up, the files gets corrupted, right? Because there will be a team of people, let's say 10 people working on this project. If everyone does this, because see, person A will be focusing on making the changes, meeting the client expectations and all. They cannot just sit and see like which person or whether his changes are overwritten or whether his changes are saved securely or not. Right? Definitely we need a system which has to take care of this. So that's the one of the reasons where version control system comes in. It allows people working simultaneously, parallelly at the same time on the same file. So this is the case without version control system. But if you had a version control system, it can allow people working on the same file at the same time. Means it will see that changes are not overwritten, changes are saved properly, secured properly. How and all we'll see in the lab. Right? This is one of the use cases why version control system is helpful. And before going into the second thing, I would like to tell you, like who uses this? It's very obvious. Developers will use this. They have their programs, they have their files, right? Code, they maintain, they manage the code. Even testers use this. They have automation test scripts. Even DevOps team uses it. They have so many configuration files like Kubernetes manifest files, Terraform config files, Ansible playbooks, any configuration file, right? So anyone in IT, everyone should learn this version control system to manage their files, because to work as a team, we'll have multiple files, right? Multiple people will be working on it. We need a system which can manage them. So everyone should learn version control system from the perspective of managing our project, managing our shared files, right? So, and also which files can be version controlled? Any files, irrespective of the language, irrespective of the configuration file. It can be a Python, it can be Java files, it can be some config files like Kubernetes manifest files. Even a simple text file also can be version controlled. Any static file can be version controlled. Dynamic files are not advised to put on version control system like exes and all, right? Any static file can be version controlled. So we are going to learn Git from the perspective of version control system, means from the perspective of managing the project, right? That's one of the aspects from DevOps, right? To learn the Git to how to manage our own config files. Like developers does that, testers, everyone should know it. So first learn it from the perspective of version control system, like maintaining the file securely, safely, maintaining the versions, backups, all of that. Right? Is that the only aspect why DevOps team use it? Of course, there is another aspect. The second one is, yes, developers place their code. As a DevOps team, just recollect the pipeline we discussed yesterday. Once developers place their code, we have to pull the code and create the pipeline, right? So that's the another aspect of using version control system in the CI/CD part. So both the aspects will be covering here so that we are good to go and comfortable in using this version control system in our projects. Right? First, we are looking into this first aspect. First, let's learn how do we manage our files like developers or anyone else does that. Right? We do have our own config files, so we need to know how Git is used to version control them. Am I clear with this? Two perspectives of using Git, DevOps perspective. Appreciate your quick responses. Are we clear with this?
Yes.
Yes.
Right. Thanks for your response. So coming back, yeah, we are talking about what is it? Like it allows people multiple people working on the same file at the same time without the project getting messed up. Second thing is um, to maintain the backups or to maintain the versions. Means let's suppose there is a file one, it's a version one. Client want to make some changes and make version 2. Let's suppose you have overwritten it and made a new file which is version 2. But let's say after 6 months, client want to revert back, go back to the previous version because this new version is not working for them. Means users doesn't like this. They want to go back. But you have overwritten it or deleted it. So you have to develop this, right? It's a rework. So to avoid this, don't ever like overwrite the changes or overwrite the older versions. Maintain those versions, maintain the backups, maintain the versions. Again, can you do this manually? Definitely not. We need a system which can manage this, which can maintain this. That's where that's where version control system comes in, which will help to maintain backups, right? And maintain backups and versions. You have different versions of it. You can retrieve any particular version as you need. And also another feature is maintaining the log. Like let's suppose something went wrong. Till 6 o'clock application is good. At 6:15 something went wrong, application is down. We need to immediately identify the change which led to this, and put the changes, put the system back, bring the system back. So how do we know that what happened during this time? So we need a system which can provide a detailed logging, like file 1 is modified by person A on line number 4 at 6:04 a.m. And what changes also, okay, line number 4. So this kind of detailed logging will help us. Okay, we will go to the log history and see, okay, these are the changes, identify the person, identify the file, identify the lines, and revert them back immediately. So how do we get this kind of logging? Again, version control system, right? These are all some of the features of version control system. It can help us with the detailed logging. During emergencies, we need to revert those changes, and this logging will help, right? So these are some of the features of version control system. It helps in multiple people working on the same file at the same time. Maintain the backup of your files. It need not be just developers. Even DevOps team, they have configurations. They have to maintain their backups. They need to know the log. Even the DevOps is a team of people. Multiple people will be working. We need a detailed log, right? So this is applicable for anyone who uses version control systems. So that's what is a version control system. And these version control systems were categorized based on their architecture. Based on their architecture, they were categorized as centralized version control systems and distributed version control systems. Let's have a look at the centralized version control system. So if you see here, centralized version control system, this is the remote repository, right? And these are the workstations of individual users or developers. Like let's say this is a developer one or DevOps person one, whoever you consider, right? DevOps person 3. So there will be a remote server or central server, whatever you call it. You may call it as central server, where all the project, all the code base is kept, and different teams are connecting to this, right? So they can connect to this, they can connect to this remote repository, get the changes back, get the changes to their local computer, make the changes and put it back. This is called centralized version control system, where the architecture is very simple. Right, here there are certain disadvantages. Like let's suppose on the central server, changes are kept. If a DevOps person has to make some changes to the configurations, they have to connect to the central server and then bring the changes back and then work on it. Means network connectivity is definitely needed. If there is no network, let's say somehow network disconnected, entire work is halted, right? Until you get the network back, entire work is halted, right? That's one of the disadvantages. And Kajal says screen is not visible. Kajal, everyone can see the screen. Can you guys confirm? Can you all see the screen?
It's available.
Yes, we can see the screen.
Please zoom the window, please click on that screen share or the zoom window. You can see that. Everyone can see it. You have to check from your Zoom options. Right, this is one of the disadvantage. Another thing is, let's suppose for some reasons this central server is gone or crashed, right? For some reasons, if this is gone or crashed, like chances of recovery are less, right? This is where everyone has pushed their changes. If this is lost, chances of recovery is less because it serves like single source of truth. Chance of recovery is less. It works like a single source of truth. These are the two drawbacks you have with the centralized version control system. And there were so many version control systems, right? Like a GIT, SVN, TFS, and all. SVN falls under this centralized version control system. SVN, TFS also falls under this centralized version control systems. To overcome these drawbacks, we have distributed architecture. Can I go ahead? Any questions in this part? Any questions till the content we covered?
Yes, you can go ahead.
Right. So let's look into the distributed version control system. If you see the distributed version control systems here, so this is again central server or remote server where all the project work is kept. And this is the workstation of individual collaborator or individual, like every user, right? This is the local computer or the workstation. So what is the difference here? Here, if you notice, every user is going to have, like every person is going to have a local repository. This is called local repository, which is a copy of central repository or remote repository. This is a central repository, like centralized version control system. We do have a central repository or remote repository, and every individual user has got a copy of it, which is called their local repository, right? Everyone is going to have it. Now, each user will not directly work on this local repository. They'll work on some other directory called working directory, some other folder, some other directory. They'll actually make the changes here. From here, changes will be pushed to local repository. From local, they'll push to central. Right? This is the two steps before their changes goes to central repository. This kind of architecture where everyone is having a copy of central repository is called distributed architecture. What is the advantage of it? It overcomes the drawbacks of centralized one. Let's suppose there is no network connectivity, right? You need network connectivity in this part, right? Let's say you don't have network connectivity. You can still work on the local repository, right? Local repository is in your local machine, your laptop. You just need to access your hard disk. For this, network connectivity is not needed. You can still continue working here. Network connectivity is needed to push your changes to remote or central repository. And also, let's say you want to get a copy from remote, you can pull. But this pull and pull, push and pull from central are less frequent, isn't it? Once in a while you do it. Let's say you are done with your changes, your requirement is completed, you may push your changes, right? Only once you need it. But this is more frequent. Working with a local repository, accessing the local repository is more frequent, right? So even though network connectivity is not there, you can still continue the work. Entire work is not halted, right? Another thing is, even though the central server is gone, chances of recovery are more because like everyone is having a copy of it. It's easy to recover. Chances of recovery are more. Recovery can be done. Right? So that's how it overcomes the drawbacks of centralized version control system. Also, another thing is because majority or most of the times they work with a centralized version, local repository, right? Majority of the times they work here, it is also faster because they just have to connect with their hard disk, right? So distributed version control systems are faster, and yes, Git falls under this category, right? Git is a distributed version control system. It falls under this category. And also now all the modern DevOps projects uses Git preferably. That's the reason we are learning it. We'll be focusing on Git yeah, to the depth. Like any version control system will work, but yeah, we are focusing on Git here for these obvious reasons. And another thing is, until anyone move their changes to the central or remote, no one else can see their changes. Let's suppose you made some config file, right? It is just in your local. No one else can see it. Unless you push it to central repository, to the shared one, then only other users can see those changes. And how to do this push, how to do the pull, and also it allows multiple people working on the same file as well. All, of course, those are all version control system basic features. Any version control system will support it. We will learn how do we do that, and all those use cases are coming up. We are understanding what is version control system, why do we need it, who uses it, the architecture of it, and then we'll get into the lab in some time. Any questions here?
No questions so far.
Right. So, yeah, this is the graph from Google Trends. This is a graph collected from Google Trends from 2020. You can also get the latest graph. It's a comparison of different version control system. Like we learned, right, under each category, there were multiple tools. And also I have suggested to master one tool under each category, right, which is very widely used so that other tools follow the similar analogy, similar concepts would be there. With self-learning, you can skip to other tools very easily, switch to other tools very easily. So you can see the graph, Git, SVN, TFS, and fossils comparison. If you see, the blue one is for Git. It's a clearly the winner in the category. So we are learning the very widely used tools in the market so that you have great exposure to them. You can easily switch into the project quickly, right? So this is one thing. And also let me just reiterate, what are the centralized version control systems we have? SVN, TFS, clear case, all of this falls under centralized version control system. And distributed version control systems are Git, fossils, mercurial. These are some of the examples which follows the distributed architecture. And out of this, again, Git is very widely used. We are learning Git in this course. So this is about why Git, why we are learning it. And this is the architecture of Git in particular. We have seen the architecture of distributed version control systems, right? Now the architecture of Git in particular, which depicts the same distributed architecture, but specifically different components with Git. So if you see here, this is the local computer, right? And like I said, you have a local repository, working directory, right? We have seen working directory, a folder where actually we make changes, local repository, a copy of remote, right? And yes, let's say a person is making changes in this working directory. So he has to move those changes to staging area. There is one more layer called a virtual layer. It's called staging area, or it is also called as index area. Staging area or index area where you have to move your changes. From staging area only you can move to local. See, it's like a two steps before it goes to local. And again, from local, it has to go to remote for to share with others, right? So it's like a three steps. This is called Git tree. Git a tree or Git a flow, how changes moves. And one more thing is this is not allowed. Like you cannot directly go this way from working directory to local or else from staging area to remote. No, these are all not allowed, right? You have to first put your changes in working directory. From working directory, they goes to staging, from staging to local, from local to remote, right? So you may be having a question, why do we need this index area or staging area? It's like a virtual layer. So why do we need it? It is needed, this virtual layer or index area is needed because it works like a preview or else a pre-check before your changes goes to local repository. Preview or else a pre-check, right? Before your changes goes to local. Again, what does it mean? Let me give a simple example. Suppose you have 10 files here. You want only 5 of them to be going into local repository. So you can add only those 5 files to staging area and see those are added to local repository. Means basically it gives you more control on what changes or how changes are moving to the local repository. That's how this staging area will work. Anyhow, we are going to see all of these things in the lab in few minutes. Right? Right? I'm just giving you an overview. We are going to see all of these scenarios with the practicals. Right? So this is one thing. And another thing is working directory, you can assume it like a folder, right? So imagine we are going to create that working directory. Okay, you create a working directory. It's a folder where you make your changes. And this working directory, local repository are like physically the same folder. Yeah, that's another interesting point. Physically, it's the same folder. Then when do you say it's a working directory and when do you say local repository? We'll understand this one. But understand physically they are same. Logically, they are different. How they are different logically? Let me tell you. Suppose you created some file here. If you just created a file here or copied, brought this file from somewhere, whatever it is, whether you created or copied from some other folder, you placed a file here in this folder, right? So then this is set to be in the working directory. After bringing this file, if you have run this command, then it is set to be in the staging area. So after this, let's say if you have run this command git commit, then it is set to be in the local repository. So it's the same folder of physical folder on your system. Same folder is called the working directory. Same one is called the local repository. But this is how logically it's different. I told you, right? Staging area is just a virtual layer. Understood this? Clear with this, everyone? How they are logically different?
Yes.
See, don't worry. We are going to see all of this with the practicals in some time. I'm giving you an overview and a better understanding so that you know like what are all these before we create them. So this is how you have your local repository. And then once everything is ready in local, you may push to remote. What is a remote repository and all we'll see. And how do you create a local repository? Right? There are two ways. One is, let's say it's a new project. You joined a team, there's nothing there, it's a new project. You have to create a local repository. So create an empty local repository, right, on your laptop. Make the changes, make the configurations, whatever. Develop your local repository, push to remote. That's one way. Another way is, let's say you joined a project, which is already running. It's a 2-year-old project. Already remote repository is there. So how do you create local in this case? Copy from remote repo and create a local repository. Right? So this is another use case. So these are the ways you can create local repository. First, today we'll get started with this. First use case, assume it's a new project, there's nothing on remote. So we will create a local repository in our laptop and then we'll develop it and push it to remote. But before pushing to remote, there's a lot many things to learn on local. So we will learn these things first before we go to the second use case. Any questions from anyone? So let's get started. If this is clear, let's go and install Git and see how you have this working directory, staging area, local repository and all. Let's begin. And always, like as long as you do the hands-on, you should keep this architectural diagram in mind. You should have this architectural diagram in your mind. right? This is how, like, you should have this registered. Of course, all of this will be shared with you. You have this presentation as well, so that you can refer this architectural diagram. And now Git works on multiple operating systems, like it works on Windows, Linux, Mac. So if you have a Windows laptop, you can directly install Git. If you have Linux also, you can install it and use Mac also. So we'll get started with Git on our laptop itself. We don't need another lab setup for this. So irrespective of the operating system, the concepts, commands remain same. Only the setup differs, like the installation differs. So let's get into this. So go to Google and type in Git download. This is the way you have to do. All the links, all the steps, everything was shared across. Like they were all available for you for the hands-on. And you can follow the steps before you install these tools. Just a second, I'm trying to share the page. You will have all these installation steps here. Git assignments, if you go here. Okay, let me show from the beginning. If you go here, or else you can go to this live demo, right? And here, if you just go here, towards the bottom, you have lab exercises. First day, yesterday, it's a theoretical and overview, so we don't have lab, but from today, yes, you have here how to install Git on Windows, on Mac, on on Linux systems. If you are using any EC2 instances, all the steps were here, so you can follow those steps. Anyway, yeah, just type Git download in your Google and go here. And you should be seeing different operating systems. So according to the one you want to choose, you can go for it. So if it is Linux, if you have some Linux systems, depending on the Linux distribution, you can use these commands. If it is Windows, right, just go here and download the executable and launch the executable, right? It will download an exe, double click the exe, it will open the download wizard, right? You can hit next and keep on continuing. Even this particular screenshots, all the steps are available for you during your hands-on. And if it is Mac, you can use brew install git, and that will help you install Git. So I'm using Mac, and again, whether it is Mac or Windows, the commands concepts remain same. Only the installation steps differ. So if it is Mac, launch your terminal, and as Git is installed for me, I'm checking it with the Git version. So it will give you the Git version, means Git is installed. So this is the terminal. You can use the terminal if it is Mac. If it is Windows, go to the start menu and you will see the and in the start menu give git bash. So git bash shell, I mean a terminal will be installed when you install git, which you can use to run the git commands. Am I clear? Are you all following? Any questions you have?
Good so far.
Thanks for confirming. And here are again the labs you have here as well. Git installation on Windows, right? You have all the documents available here as well. So here, if you see the Git installation on Windows, like it will download exe and you have to double click the exe, right? Installation wizard will launch. Even all those steps were available here with the screenshots, so that it helps you to do the installation with a very ease. So you can just hit on next and keep continuing, right? So you have all the steps, and once it is installed, go to the start menu and give git bash in Windows. It will launch the git bash terminal where you can run the commands. So you have all the references, materials, all the guidance available for your hands-on, so that it shouldn't be, nothing should stop you from going ahead with your hands-on, right? All right then, so let's begin. So this is my Mac now. Okay, fine. Git is installed on the system. So how to use Git to version control a particular folder or a particular directory, right? How to do that? So first let's create some directory. I'm going to my desktop. I would like to create some folder on the desktop. Okay, this is the desktop. I'm using cd change directory, a simple command from the command line. If you are comfortable with the UI, you can also do that. Like you can just go here to your desktop and create some folder. Anywhere you can create some folder. I'm just creating some folder which I want Git to version control it, Git to track it. So you can right click here and create a folder, or else you can also do it from command line. We will learn this Linux command separately also when we start Linux, but these are just basic commands. I'm creating a directory called git demo. Okay, now go to this folder or directory, whatever you call it. So I'm inside git demo. It's just an empty folder, but now I'm going to create, let's assume I'm a DevOps engineer. I want to put all the config files, everything in this, and I want Git to version control it. So how do you tell Git to version control this particular directory or this particular folder? It is there installed, but how do you tell Git, okay, this is the folder, you have to track it. This is the folder. Also, I want to make this as a working directory or local repository. Both are same, right? So how do you do that? You have to initialize Git or start Git or tell Git, okay, this is the folder you have to version control. You have to make this as a local repository. So for this, run the command called git init. Git init means initialize Git, start Git, right? So that whatever files and subfolders also, if anything are there in this folder, Git will version control them. So do git init. So if you see, it has created some .git folder, a hidden folder. Hidden folder can be seen with ls-a, or else you can also check it this way. Just go to this git demo. We should see the hidden files here with the command base. Somehow it's not showing up. Okay, so anyhow, here you can see the .git. If any folder is having .git, this git demo is having .git means it's a local repository, right? Local repo, you have created a local repository. Sometime back we are talking about the use case, right? How do you create local repository, right? This is how you create a local repository. First use case. Can you relate to this? This is the one I'm talking about. Create an empty local repository first. Assume it's a new project. Create an empty local repository. Develop it, and then later on we can push it. So that's the use case I'm talking about here. Right? So yes, local repositories, this is a local repository. Yes, this is the working directory. You may give any name. I have given it as git demo. This is where I'm going to put all my project files. Right? Okay, fine. A local repository is created, but there are no files. Let me create some file, right? Let's go to that folder. Hmm. Let's go here and we may create some file here. Yeah. You may create some file and save it here, or else you can also create from here like touch file1.txt. I'm just creating some text files, right? We are not bothered or interested about which type of file or what it is, because our focus is on using it to version control it. Later on, there comes the real files like Kubernetes manifest files, Terraform config files, and so on. So because we did not learn that yet, we are first learning it. So use any file so that we learn the concepts, and once it is like once we complete it, we'll be keep on using these commands to version control our real projects, right? So I'm just creating some file using touch. So file is created, right? So where is this file? Can you tell me? Like we discussed some time back again. Logically, I mean, physically, it's the same folder, but logically, it's different. We just created the file means where is this file set to be in? What do we call it? Where is this file?
Maybe the branch, the master branch of your local repo.
Actually, we were talking about working directory, staging area, local repos, right? So we just created a file means, yes, physically it's in this Git demo, right? It's here in the Git demo folder, but like logically, what do we call it? Where is it? Just created the file means it is said to be in the working directory, right? See this architectural diagram. You just created a file. It is said to be in the working directory. How do you confirm? You can check Git status. It tells you that untracked file means Git knows there is a file, but it will not track it. It's asking you to add so that it can track it. Do you see the hint here? It's giving you a clue. Git knows there is a file, but Git is asking to add so that it can track it. Git add file 1. So this is what after adding it, where does this file goes? Always refer to this architectural diagram. It's in the working directory. So if you add it, it is said to be in the staging area, right? So let me add it. Now again, if you see the status, the message would be different. See earlier untracked file, but now it's not saying it's untracked. It is tracked. Git is tracking it, but you can commit that, right? So now the file is said to be in the staging area. Let's say I'll commit it. How do you commit? Git commit -m. M flag is mandatory. M means message. Some message like relevant to what changes you are doing. Let's say it's a first file. Done, right? Now do ls git status. It says working tree is clean, means whatever changes you have, all are set to be in the local repository. Now this file is set to be in the local repository. You got the logic and the difference? File is in the same folder physically, but logically that's how it's different. We call it as working directory, staging area, and local repository. Is this much clear for every one of you?
Yes.
For whoever having any confusions or it's not clear, let us repeat it with another file. I am creating another file, touch file 2. Okay, another file is created, file 2. Can you tell me now where is file 2? I am expecting responses from everyone. Be attentive and let's have interactive sessions. Where is this file 2?
Working directory.
Yes, it's in the working directory. How do you know? You can check this. Again,
Yes.
file 2 is untracked, right? Because it's a new file, you did not add it, it is set to be in the working directory. There is another way to check also. ls is a simple Linux command which will check the list of the files, right? Like which will give you list of the files in that particular folder. But git ls files will give you files in the staging or local repository. See, only file 1 is listed. Got the difference now? Now, file 2 is in the working directory. I want to put it in the staging area. What should we do?
Git add.
Right? So this command will add the file, will move the file to the staging area. At this point, if you see status, yes, it's not saying untracked, it's saying changes to be committed. Means, yes, it is in the staging area. You can also see this. Yes, both are listed now. Now commit the changes. Git commit -m, some message, a relevant message so that you can understand what changes this is about. After making change, after put it in the local repository, if you see the status, you can see it's a clean. Good. Understood now how the file moves from these different areas. See, this is very important. Understanding local working directory, staging area, local repository is very important. Initially, we begin with the changes in the working directory. Eventually, we put it in the staging area and then to the local repository.
Got it.
Right? So this is how we have our changes moving from working directory to staging area and staging area to local repository. So that's what we are seeing practically here. These basics are very important because we see people working on Git and all, but without having the clarity on these basics. These are very important so that you can troubleshoot any sort of scenarios in your real project. Also, any sort of interview questions can be cleared, right? We are learning it as a first tool in the beginning, because like from once we get started with our Jenkins or Maven, we have our files, we have to work with the developers projects, like we'll pull those code and all, right? So we should know Git so that we'll be using it throughout the course till the end of the course. Of course, then we'll be using it on the real projects, so like real files, like all the config files and all. So that's the idea of learning it in the beginning. So are we all good with this much? Like simply adding, committing, these are the commands we have used till now. Git status command, git add command, git ls files, git commit. Right? Whenever you run git commit, whatever in the staging area, everything will be committed. Right? Also, what happens whenever you commit, whenever you run the commit command, at the backend, a commit ID will be generated. You can see that with a command called git log. Like we discussed, right? It will provide you a detailed logging. Right? Git log will give you the history of the commits. And whenever you run this commit, a commit ID, a unique hash code will be generated. You can see all of these details with git log. See, I run commit command twice, right? 2 times. So you have those details, the commit ID, the author who made the changes, and the timestamp and the commit message, right? How do you get this author name? When you are running this commit command for the first time, it will prompt you for the username and the password. Just a second, they should be available here. See, whenever you are running git commit for the first time, you will be prompted. You should be running this command like git config global username, put your username and some email ID for git to track those changes. Right? This is only one time task. It doesn't prompt for me because it's not first time I'm using it. So for the first time, it will prompt you. You can provide these details. Commands are here, so that it will track using those. That's how I got these names here, right? And the timestamp when those changes were made and the commit message, right? Because see, after some couple of days, we may forget about what this commit is doing. Commit message is very important. It's like some comments. You comment it so that you understand what it is all about, right? That's how you can track those changes. And if you just want to see a brief log, not the entire detailed log, just a brief log, git log one line. It will just show you first 7 characters, because first 7 characters are enough to identify the commit. You don't need the entire commit hash and the commit message, right? Clear? Is that making sense?
Yep. Yep.
So these are all the simple and the very basic parts we were discussing, and we have some bunch of files here. Till now we are creating new files, adding the file to staging area, moving to local. Here you have to make another point. We did not go to remote repository yet. I did not push to remote. Before pushing to remote, there are lot many things to do here, like I said. So we'll focus on that before we go to remote. All right. So we were still on our local. And yeah, before going to remote, let's look into many other scenarios. And the first scenario is, till now we are creating a new file. Shall we see modifying the file? Editing the file. It's not that you create always a new file, right? You may have also to modify the file. Yep. Let's get into it. Let's see modifying this file. You may modify using Linux commands like a Vim editor, or else you can just open this way and modify. It's up to you. I just added a simple dummy line because, like I said, we are not focusing on the content. We are using some sample files here. So add some content. Yeah, it is saved. I just added one line, right? I made a change. Let's see what happens as you make a change. Check with the Git status. So you can see here, changes not staged for commit. Do you see the difference? It's not telling you it's untracked, right? It's not telling you it's untracked. Rather, it is telling you changes are not staged. What does it mean? Where are those changes or modifications? Not staged means where are those modifications or
On
changes?
your working directory only.
Exactly. It's in the working directory, not stage. They are in the working directory. But the message is different. You should also have clarity on the message. It's not untracked because it's already being tracked. File is not a new file. So it's tracked. It's already there in staging area, but there are some modifications. So that is the difference. So what you should do, here you have to remember one more thing. Git works with respect to changes or modifications, right? Means change or modification means it could be creation of a new file, it could be deletion, or it could be modification. It could be anything. Git works with respect to changes. Change could be creating a file, deleting, or modification, and whatever it is, it follows the same flow. First, it will be in the working directory, then it goes to the staging area, and to local repository, whether it is a modification or a new file, whatever it is. So that's why the modification is in the working directory. So what you have to do again, you can do git add, git commit this way separately, or else because it's not a new file, you can also do this way with a single line. Git commit -am file modification. -am means add and commit. You can do this because it's not a new file. Means it's not an untracked file, right? It's actually unstaged. You have to know the difference between untracked and unstaged. If it is unstaged, you can also do this or with a single. Both are possible. Do you understand the difference? What is meant by untracked and unstaged file? Yes.
Untracked means the file is new. Unstaged means already file is available. Just some modified stage. Yeah.
Exactly. Yes. Untracked means it's a new file. For the first time of creating a file, if you see status command, it will show like untracked changes. Then what you should do, you should add and commit like this separately only, right? If it is unstaged, it would show you like unstaged means changes to be committed. Means to be committed means it's not committed, it is unstaged. So in that case, you can do with a single command this way, or else you can also do it. You have two ways to do it here, right? -a means add and commit. Understood? So yeah, we can go, it's an unstaged change. That's the difference between unstaged and untracked. Again, like this clarity is needed. Like what is unstaged and untracked changes. And I would like to use a single command, -am file modification. Right? Good to go? Is this much clear for everyone? Can I run the command or any questions?
No question.
Please, I have one question.
Yes, please.
Yeah, is there any other way, like we did the unstaged command in one single line? Similarly, can we do it in untracked as well?
No, you can't do it. That's why it's having only one method. Whereas for unstaged, you can do either ways. You have
Okay.
to do it separately only for untracked. You can't do it with a single command.
Okay, thank you.
And
So
ma'am, what
hmm.
is that file modification? You means you tag the file name, right?
No, it's a message. M stands for message. It's a user defined, your own message you can give. It's like a comment. That's what I mean. It's like a comment so that at a later point of time you can identify what this commit is doing.
Okay.
Your own message. Like here you will see that message. In the commits you will see, right? See file modification. This is your message or comment. So that later point of time after 6 days, if I see, okay, what this commit is doing, this should give me a hint. Okay, here in this particular comment, we have modified it. So with relevant to our DevOps, let's say we are making some changes to our EC2 instance. I'll put the command EC2 changes were here, like EC2 as a comment, something like that. So that a relevant one, so that I can understand what this change is doing actually, right?
Yeah. Okay.
So now the project is clean, like whatever are there were all committed. So that's how you even modify the changes, right? Again, the log, you have everything. Git is a very simple tool. At the same time, it's tricky as well. Initially, for a beginner, it might be tricky at times, but practice, hands-on will clarify the things. If you learn it with clarity, you can enjoy working with Git. If you don't have clarity, if you have confusions on the basics or the fundamentals, it would be always confusion and difficult what you are doing, where are you committing kind of things. A lot of confusion will be there. So clarity is very important. The basics, the fundamentals should be strong. That's a focus we are doing as of now. And then we'll step into the advanced concepts. These are the very basics. But everyone, like we should have great clarity on these things before we step into the other things like conflicts, branches, merges, stash, rebase, lot many things coming up. And this architectural diagram, like I said, whenever you are doing any commands or anything, this should be running at the back and this should be registered in your mind. You relate to these things. Okay, it's in working directory means next it should go to the staging area. Then it should go to the local repository. This kind of clarity you should have. And just a reminder, we were working here. As of now, we are in this part. Okay. So this is my local repository, right? So this is confined for myself. No one else can see my changes. These are just for local purpose. Like we were working on this, and whatever commands we have used, again reiterating, help for you so that when you do the hands-on, see here you have everything, creating a folder, navigating into it, initialize Git, right? Like creating a sample file. We created README file, whatever. You can create any text files or readme files, or if you have some programming knowledge or scripting, you can use it, or simple text files also will do. It's up to you which type of file you create. Any static files can be version controlled. Even explanation of every single command is here. So the expectation is that after the class you have to complete this hands-on, untracked versus unstaged, the differences, everything here. This is the day one lab. And like once you are good with the lab, pick up the quiz. I'm sharing the quiz today for the class. Let's have the quiz here itself for today. As it's a day one, let me take you through the process. Go through the quiz. You will also see your results. I'm sharing it in a Zoom chat. If you have got registered, if you got access, you can also have it from there. Can you answer those queries now? It's just to reiterate your understanding which you have learned today. Have you all got the page?
Yes, received.
You're right. Any questions you have in the topics covered today? Here also link is there. You can also go from here. And in the next day, we have something like where we'll see deleting the files. Till now, we created the files, modify the files, right? We have to delete the files and see how Git works on it. And how do you exclude certain files from version controlling, right? These are the interesting concepts coming up. Like a git diff commands, git rm, like how do you remove the files? How do you exclude the files from version controlling? And from here on, advanced concepts begins like a reverting, reset, right? Differences between revert and reset, branching, merging. These are all the topics for tomorrow. As it's a day one, I have gone through the architecture and the very basics so that you can set up your lab and do the basic stuff and get prepared for all these advanced concepts which begins from tomorrow. Hope you are all into the quiz. It's a simple quiz to check your understanding. And once you submit it, you will also get the results.
Can you please see your Git window once again?
Okay. Yep. Yes.
No, not this one.
Yeah, which one you want me to go through? The quiz page or this one?
Second.
Hmm?
Second window, no, there is a file C, right? File 1, file 2.
Okay, this one.
1 minute.
Assignment one.
No. C. Okay, after creating a file, where to see? Creating a file in second window, no, file 1, file 2. After creating in terminal, right?
You can see with ls this way, or else you can open your Windows Explorer and see here. You can open your Windows Explorer this way.
Okay, all right. Yeah, this one, right.
Okay.
Hi, Preeti, I have one question.
Yes, please go ahead.
See, once you initialize the git init command, it will create dot git folder. Okay, inside that, what and files will be available? Can you show me that?
Okay. In the .git you are asking?
Yes, yes, yes.
In
How
the
they are?
.git you will have all the metadata.
Okay, yeah.
Give me a
Can
sec.
can you show me how they are arranging that data, different files?
We don't have anything to do with this. I'll show you, but you have nothing to do with that .git folder.
Just for the
I'll show you. I'll show you.
just for the understanding.
And yeah, I'll show you. Meanwhile, I'm launching a poll. Can you guys please take a minute to answer this query? This will help us to understand you better. Have you all received the poll?
Yes.
Okay, Raviteja got 8 score out of 10. Good score, Raviteja. You can retake the quiz as well. Go through the recording and again you can retake. Thank you, Hardeep, for completing it. And yeah, I'm going now to that .git. Yeah. You'll have all the meta information of how your files are organized, like how the commits are and all. But we don't have anything to do here. Can you all see the poll? Everyone, you got the poll and the quiz as well, right? Nothing is missed. Just make sure you received both of them. All the commands we have used were there on the learning portal on the website, as well as the references, additional references and all. I'll share it tomorrow. You have all those documented. You can set up your Git and get started with your hands-on. By the next session, if you have any questions, you can ask us. Also, there's a separate WhatsApp group for registered students, a private WhatsApp group where you all will be moved there so that you can post the screenshots with your hands-on once you are done with it, or if you have any questions.
Uh, Hello.
Yes, hi.
Actually, hi. Actually, thing is, this one, if I go for the practice, then it's not required any laptop configuration or anything. Like we can complete all the things, all the practicals through the cloud basis.
Yes, correct. You don't need anything. Only Git we are starting in on our laptop. Even any basic laptop will support it. Also,
Okay.
once we get into our cloud lab, we don't need the Git on the local also. For now, we are getting started with it. Yes, you don't need any separate configurations. Any
Okay.
We do the most of the lab on the
Okay. Okay. Actually, I'm a SCCM server engineer. In this time, they are asking for that when I'm going to practice on that before 5 year. That time they are asking for the VMware SSM. It's required a particular configuration of this computer and laptop.
No, no, we don't need anything here. That's another advantage, and that's the way we have sorted out so that people, like different people, will have different kind of laptops, kind of concerns and restrictions, right? So everyone can do comfortably the lab on cloud. We will get introduced to that lab once we are done with the Git. Because Git is very light tool, lightweight, it can be going with any laptop. So you can just get started with it. But once we get into the other tools, yes, we'll switch over to the AWS lab. And that will be just same, like I said, right? Only setups differ. Commands, concepts remain same whether you do it on your local or on cloud. But yeah,
Okay.
that exposure also you will get once we step into that cloud.
Okay, you means totally if you cover a enter the cloud with the DevOps and after the course also same thing. But in between this course, if I am going to any practice and anything, so it's not require any particular configuration. Any configuration we can handle.
Yes, you can handle it.
Okay, okay.
Preeti, I have one more question actually.
Yes, please, Praveen.
Preeti, are you covering GitHub administration activity? Actually, currently I'm working in support as a DevOps engineer. But I need more information of administration activities. Are you covering GitHub?
GitHub will be covered. So
Uh,
once GitHub is covered, you can also work comfortably with Bitbucket. Both are similar again.
yeah, similar only. Yeah.
Administrative part, the administrative part will not be covered. It will be covered from the DevOps perspective, like DevOps development. DevOps development in the sense you create the pipelines, you
Yeah, yeah.
on those pipelines. So that's the perspective.
Mm,
Administrative or the settings part would be a very little part there, and the
mm,
DevOps focus would be a little there. So
mm.
with that wouldn't be covered here.
Okay.
And another reason is like the GitHub or Bitbucket, if you take remote repositories, the administrative part, like when you go to the settings, those things will be org specific. Like let's say you are in one company, you are in some organization, they have their own rules or their own customization, their own security norms, how the administration would be dealt with, right?
Yes,
Like
I
when you talk
understand. Yeah.
about hooks or when you talk about the checks, whatever it is, those are org specific or project specific sometimes. So generalizing those things and covering those things wouldn't help in any way. Those are self learn. You can just self learn those things. So
Okay.
that's the idea of not including them
Yeah,
over.
in our organization, we're using LDAP. Yeah, permission related activities.
Yes, someone uses something else and their merge checks, their
Mm.
webhooks will be different.
Mm.
Each one has their own. But
Oh.
those are little exploration, you can work on them.
Mm.
Those are org specific things, right?
Yeah, thank you.
And so have everyone completed the poll? Almost 82% have completed. Whoever have not, can you also please go through it? Also, the idea is like we are seeing the experienced people, different experience levels, people from different backgrounds and all. We need this data so that we want to just come back to you to get the feedback how you are doing with. If anyone fresher, non-IT people are there, we just want to have your feedback as well. Of course, everyone's feedback, but particularly who are more coming from different backgrounds. Like I said, right, this is a very basic stuff we covered today. Okay, but from tomorrow, like, it's a day one
Priti,
of it. Tomorrow we'll get into the yes, please.
Priti garu, actually, one thing is there. Is there any particular study is there? Like I'm completed the BA here,
Mm-hmm.
so I'm not a BTech background,
Okay.
but I have experience with that everything like IT, like server and hardware networking, everything I have experience on that. I already work. I have experience with the 10 to 11 years completed.
You are into IT, right?
Yes, I'm in IT, but I am not in the BTech and MCA background. That's why I'm asking.
No problem. Those backgrounds will not related or will not do anything here, right? Like we discussed yesterday also, people from any background can
Any
learn this.
background? Okay,
Only
okay.
the things, like as a
Actually,
new subject, we are learning it from the beginning till
uh,
advanced. That's all. We don't need any backgrounds of that. Just
uh,
having people so that we want to know like how you are following the things.
yes, yes. Actually, before 10 days, the one person asking me that what is your qualification. When I discussed with him that this is the qualification, so he told me like that, no, it's not eligible for this. That's why I'm asking. Because once I give the payment to you, and after that, this type of things, and that's why I'm asking.
Okay, is it from our end? Is the person from
No, no, it's not. It's a different. It's not a IT. I think some
okay.
Amirpet area, Hyderabad Amirpet area.
We don't need the take the name, but just I want to know it's not our team, like because we
Okay,
don't
okay.
need any background to come into IT. Even to get a job into IT, we don't need to bother about our engineering I mean the
Okay.
graduation details or whatever, right? Anyone can come into IT. Even for other people nowadays, I see people, even people from law also coming into IT. I have those examples also. So we
Sure.
strongly believe the background has nothing to do. For me personally, I came from electrical and electronics, of course,
Sure.
BTech, but electrical and electronics, it's no way related to software and all. But I'm doing very good here. So actually, backgrounds doesn't do anything. Only the thing is, you are learning a new subject. You have to learn very thoroughly from the basics till advanced. It's not enough if you just go with the basics. It's not enough you just go with the advanced without skipping the basics. Both will not work. We need
Okay.
to have that proper design and clarity, learn from the basics with the strong fundamentals, and then your advanced, like you can work on the real projects. So no background will do. Only the thing is start from the beginning. I mean, learn from the beginning. You don't jump onto the advanced topics because you're an experienced guy, or you don't just stuck up with the basics because you are a fresher or non-IT person or coming from different DBA background. You have to learn it thoroughly. That's the thing we have to make sure. Any subject, anyone can get into any field. Only thing is you have to show that in your resume. You can uh, like showcase your skills in your interview. That's how interviews will pick up the candidates, not because by seeing their background and all.
Okay, okay.
The poll is again, I'm telling you, this is to just get to you guys and see like how you are doing well or wherever you stuck up, so that we can provide our extended hand, helping hand for everyone. Anyone can avail this help. We'll get back to you guys. Also, you can reach out to us. The poll says the percentage, but still, if you want to let us know or talk to you, you can feel free to reach out to this number on the WhatsApp, right? So that you can get the better career counseling and the guidance. Any more questions from anyone? As it's a day one of GIT, we just covered a little part of it, but I want everyone to be thorough with it. Take some time, do the hands-on, get thorough with it, and let's begin deep dive from tomorrow. Okay, Raviteja has a question. Up to how many years we can apply for DevOps job? If you are like thorough with the concepts I cover here, you can easily claim 3 to 4 years. Yesterday also there was a question from another participant, like if you are from lead position kind of, so can you claim the same position in DevOps? Definitely you can, because the topics covered here are far advanced. Even an experienced guy may not be getting such exposure. So definitely all of those are covered, and you can put those scenarios in your resume and claim your experience, or you are a lead over there. But again, you have to gain that expertise. Means we need your time and effort and your dedication, completing the labs on daily basis and proactively picking up the quizzes and testing your knowledge. And if you are stuck up somewhere, reach out to us. Use all the resources we are providing here, utilize them to the fullest and gain the benefit. So that's what we say. So minimum you can claim 3 to 4 years if you expertise this. Any more questions? Anything you want to know? I think I made clear about the lab, the course content, the learning portal where you have to go through for all your hands-on things, and the quiz portals, everything. Still, if you have any questions or anything you need to know, you can reach out to us. Okay, there is a question from Raviteja, DevOps versus SRE versus platform engineer. Okay, Raviteja, let me answer this question. DevOps, like you know, it's about automating the whole process, right? From the desk of a developer till it reaches the production table. The whole process can be automated, which is DevOps. And also optimizing this process, how better you can make this process. That's all with the DevOps, right? SRE means site reliability engineer. Again, these words are interchangeable in some projects, in some organizations. But strictly speaking, SRE is reliability engineering, meaning, okay, you have these pipelines. Okay, these pipelines are, okay, let's say you have a Jenkins server. How stable is this Jenkins server, right? How frequently it's going down? Or else, let's say there is some service. How stable this service is, how much percentage there. SRE talks about different parameters or metrics like SLOs, SLIs, kind of, right? The service level agreement, service level objective, service level index, all of these things would be calculated. It's a separate kind of metrics kind of thing. More on-call support would be there for SRE role. It's all about stability and reliability of the systems and services and calculating the error budget. All of this comes under SRE, right? Once the pipelines are created, once you have automated it, how stable the system is. That's the focus for SRE. Platform engineer. Platform means the environment. Let's say it could be on-prem or it could be hybrid in the companies. Means it's a combination of like a private cloud and public cloud, or else it could be a public cloud. So whatever it is, all this comes under platform. So platform engineer is nothing but who will work on configuring this platform, who will work on managing or maintaining stability for this platform. Like there could be issues related to application, or there could be issues related to the platform. So there could be engineers dedicated to look after the platform. Again, DevOps engineers comes into that, or cloud engineers comes into this picture, like depending on the environment. Hope that answers your question. And Gayatri has a question. Okay, let me go to the questionnaire. Do we need to take, oh, lost the question, 1 second. Okay, Raviteja's question is a continuation question. By learning this course, can we apply for SRE or platform engineer? You have to apply for DevOps engineer, Raviteja. Platform engineer depends, right? If it is on-prem, you need it to be an admin for that, like a Linux admin or else from an admin background. If it is on-prem, if it is a cloud combination, you should be a cloud engineer, a separate dedicated role for cloud who look after all the cloud services, managing the cloud environment. So here you can apply for DevOps engineer, right? So coming to again Gayatri's question, do we need to take any other Azure certification as well? Gayatri, certifications are not mandatory. Okay, certifications are good to have when you have experience or expertise, means if you have learned everything here thoroughly, then you can go for certification, but not Azure certification. That's a cloud, again, that comes under platform, right? So you can take up certifications, DevOps certifications. There are very less certifications for DevOps, entire DevOps. Rather than going that certification, you have to go for certification on individual tools for DevOps. That's the right approach. Like Kubernetes certification, Docker certification, Terraform certification, individual certifications are there for each tool which have got good demand. Those things you have to pick up. Where do we get to know about the points of quiz? Once you submit the quiz, you will get already the score, Hardeep. You can check the same quiz window or email also. It will be, you will also receive an email. And there's a question from Amit. Can I change my experience in DevOps as I'm a fresher in DevOps? Can I change my experience in DevOps? I think you are already in IT, right, Amit? You are already into IT and you have some experience over there. You can still put that experience and claim as a fresher in DevOps, or else you can also add some of the tools and technologies in the previous projects and claim that you have implemented DevOps in those projects as well with the knowledge and expertise you gain here, so that you don't become a fresher in DevOps. It's up to you, like how you want to showcase and progress yourself. More of such questions, if anyone have, yes, you can reach out to us on this number, or you can also message us in the general group. We will reach out to you, or else you can call us on this number. 90% of them have completed the quiz and the poll, and whoever have not, please take a minute to complete that as well. And so that's all for today from my end. And let's get prepared for tomorrow, right? Currently working as an application support specialist, can I switch easily to DevOps? Definitely, Vishal. Like whatever solutions you are providing as an application support, the same. See, again, as we got this question, let me tell you, we are learning DevOps, right? There are again two ways of implementing DevOps, or else two types of teams or projects. There will be a DevOps team who will be creating the pipelines, who will be configuring those Kubernetes clusters, who will be helping with the deployments, all of these things. This is one kind of DevOps team. There will be another kind of DevOps team who will be providing support for those pipelines, support for those already clusters will be there, or Terraform configurations will be there. If something is broken, they come into picture for support. Means there are two things: DevOps development. DevOps development doesn't mean again DevOps team will go and do the development. Here development, I mean DevOps team will create the pipelines, everything from the scratch. And another thing is DevOps support, means if, okay, pipelines, everything are there. If something is broken, they'll provide the support. So there are two types of things. So when you go through the job description or in the interview, you can talk to your interviewer and understand the exact role. So now coming to the Vishal's question, he was working as an application support specialist. Yes, you can switch to DevOps. Like I said, you are providing application support, right? Like it might not be the DevOps approach, but here you again provide the same kind of support with the DevOps strategies or the DevOps methodology. So it's easy to whatever you are doing manually there. Let's say if something is broken or something is blocked, you might be logging into it, checking the servers, or else checking the application configurations and all, right? Here you do in the A DevOps method means your application might be running on your container, or else it might be like deployed through a Jenkins pipeline. So these are the differences. Whatever you have done manually, you'll be doing it in a different approach.
Yeah, right. Okay. Thank you.
All right then. So that is all from my end for today. Please use the same link for tomorrow as well. If you have anything else to discuss, feel free to reach out on this number. And thank you all. Good day, everyone. Happy Monday. See you all tomorrow. Bye, everyone.
Thank you.